Hi and welcome to another very exciting tutorial in our series 24 Days of Swift Tutorials this Christmas season 2017. And today at day 2 we're focusing on handwriting recognition using the MNIST model, CoreML, and the Vision framework. This is going to be really cool. And just a quick reminder, I have created a Slack workspace for our community so that you can ask Swift specific or iOS, macOS, tvOS, watchOS specific questions in this Slack workspace. And I hope that this is a place where we can help each other out and you can help each other out. And also from time to time, I hope to answer some of your questions there. And now let's get right started with our handwriting recognition application. And if you've seen yesterday's tutorial, then you're already familiar with this demo application. We have created this doodling area or this canvas in yesterday's tutorial. So if you haven't seen it and want to learn how to create that, check out this video as well. And what we can do now actually is drawing such a number, hit recognize, and then this digit is recognized by a machine learning model. So I could also draw an 8, for example, here, and this is recognized as an 8. And we're using machine learning here, or the CoreML framework that was added with iOS 11. And this is really cool and very, very powerful. And if you haven't seen how to work with CoreML in detail, you can watch one of my earlier tutorials on that. And I have found a great website, which is called coreml.store, that has a lot of machine learning models already converted to the machine learning model format that we need to work with Xcode. And if you scroll down a little bit, then you will also find the MNIST model, which predicts a handwritten digit. And just go ahead and download this model from this website, which is really simple and really cool. Check out the other models if you're interested in some of these machine learning models. And if you have downloaded them, I already did that, then you can also download the canvasview.swift file in the video description below. This is the file that we've created yesterday. And with that being said, we can actually create our new project, opening up Xcode, pressing Command-Shift-N on the keyboard, and creating a new single view application. I'm going to call that MNIST recognition, or MNIST handwriting recognition. Put that on my desktop. And then the first thing that we should do, and I'm going to place that right here, is adding these two files to Xcode. So let's first say, let's add the MNIST model and make sure that you copy items if needed, and also make sure to add this model to our targets, which is our MNIST handwriting recognition project. And also let's add our canvas view right below the MNIST model. And if we have a look at this model right now, then you can see that Xcode automatically generated the required classes for us. It says here automatically generated Swift model class. We can even have a look at this class here, and this is going to be really helpful because we can use this model in a second together with the Vision framework, which is responsible for computer vision, and the Vision framework, also introduced with iOS 11, and CoreML are seamlessly working together. You're going to see that in a second. And also we learn here what we should actually input to get the best results from this model. And it says here that the images that we put into this model should be grayscale and should have a size of 28 by 28 pixels. And what we get is a prediction with a dictionary, which gives us an array of predictions mapped to their indices. And we do not really have to worry about that because we are going to use Vision, and this is going to be really, really cool. So let's first of all start with the very simple user interface. I'm going to add a UI view here at the bottom. I'm just making that somehow squared. Let's say 375 by 375 pixels right here. Put that at the bottom. Let's add two buttons here, one button at the left, one button at the right. Let's change the background color here using the attributes inspector and change that to black. Let's call that button here clear. And let's call this button here recognize, recognize. And then we also need to adjust the size here a little bit. And then we're done. And also the last thing that we need is a label. I'm going to put that in the top right corner and make this a little bit larger, center it, increase the size here, very strong. And let's change the initial value just to 0 here, and I'm also going to make that heavy so that we can read our recognized number. And as you can see, I've already made this a squared UI view. This is going to help us later on because our MNIST model requires us to put in a squared image. And also I have made this background black because then we get the best results and we do not have to do so many conversions here. And what I also would like to do here in my canvas view is to add a little extension to UI image so that we can actually grab an UI image from a view. This is going to be very handy, so I'm just writing an extension here for the class UI image so that we can just use our UI image and call a specific initializer here. And this is going to be a convenience initializer with a view, so convenience init with a view, UI view. And what we want to do here is actually taking kind of a screenshot from our image, from our UI view or our canvas view using UI graphics begin image context with a specific size. Here we are taking the view, its frame, and its size to create such a screenshot. Then we're using the view, the layer, and we render it in a context. We're using the UI graphics get current context here, and then we're creating an image using UI graphics get image from current image context, and then we're simply using UI graphics end image context here to end this operation, and then we're using self init with a CG image and using our image constant that we've created, unwrap it using CG image, and we're actually done. And we should also unwrap our UI graphics get current context function here so that we get our rendered layer here. And with that, we can actually perform a screenshot operation by just passing along a UI view to our image, and we're getting an image from a UI view. This is really, really handy. And then the last thing that we should do here in our main storyboard is actually making this black view now also a canvas view. And with that, we have done all we need to actually have a drawable area in our application. So I'm just quickly running this now. And as I said before, if you're interested in how you can create such a drawable UI view or such a canvas, then just watch yesterday's tutorial. And as you can see here, we can simply draw something in this view. And now what we also have to do actually to clear something here is to add an outlet for our canvas here. So I'm opening up the assistant editor here using the assistant editor button in the top right corner, pressing Control on my keyboard and dragging to my assistant editor, calling this canvas view. Let's do the same thing for our digit label, and then we're needing two actions. The first action for the clear button, let's call it clear canvas. I'm making this an action, not an outlet. And the last thing that we should do is implement the recognize action, also changing that to an action, say recognize digit right here. And with that, we've prepared everything in the UI that we need. We can open up the view controller, do some of the easy stuff first. Our canvas view has a function that is called clear canvas. With that, we can clear our canvas. This is pretty obvious. And now we can actually focus on the interesting part, which is dealing with CoreML and the vision framework. Since we are dealing with images here, we can directly import the vision framework here on the top. We do not have to import CoreML, because some of the functions of CoreML are also part of the vision framework. And when we're dealing with the vision framework, then we're also dealing with vision requests. And these requests can be multiple requests that we have for a single image. So we can create a requests array here at the top, adding an array of vn requests right here and initialize that. And with that, we can also start set up our vision framework, or set up the vision framework for our purposes right below view.load. Let's call this function setupVision. And what I'd like to do now here is really cool, because now we are actually doing some classification. We're on handwritten text. So what I do to create now a vision model from a CoreML model is to use a guardlet statement here, because there could be an error that a possible error that could occur here, and I'm calling this constant that we're using here now vision model. And now I need to try something. What I need to try is using the vision CoreML model initializer for a specific machine learning model, which is in our case the MNIST model that we've imported into our project. And as you can see here, this is already available to us, and this is the class for model loading and prediction. And now, if I add this call here, I have to actually initialize that. This is just our initializer, and then we can access the machine learning model right here. And this is actually what could fail. And if this fails, we're adding an else statement here, and we're simply printing a fatal error message. Let's say cannot load vision ML model. And with that, we have a vision model that we can use to classify something. And therefore, we have to create a request for vision. And now let me create a classification request right here using a VNs, or a vision CoreML request. And here again, we pass along a model and also a completion handler that we are going to add in a second. So first of all, let's add the vision model here as a model for our request. And then we also need this handler, and this is something that we're going to put right below our setupVision function, and I'm going to call that handle classification. And such a handler requires two parameters. First of all, the request, which is a vision request, and also a possible error, which is simply an optional error. And with that function ready, we can actually pass that along to our VN CoreML request initialization. And here we're simply using self and handle classification, and we do not have to add any parameters here, just the function call self handle classification. And then we're using our array self requests, and we're passing along our classification request. And with that, we have prepared the vision framework for what we're actually going to use it for. And then we also have to call the setupVision function in view.load so that we can work with it. And with that done, we can actually implement the handle classification function. And this is something that works with almost any visual recognition tasks that you have. Because what we are going to do is, first of all, again, using a guard let statement, because something could go wrong here, and creating a set of observations. And into this observations object, we're putting the results of our request. And these results as an array, we can get this from the requests object in our parameter list. And if this goes wrong, then we're simply printing something like no results. and then we should also return, because then there is nothing we can do right here. And now what we can do is, from these observations, we can get a list of classifications. So let's add a classifications object right here. And now we're passing along our observations array. And with that done, we can actually do some operations like flat map. And for the flat map operation, we're doing a little transformation with all of the elements in our observations array. First of all, these are objects of the type any, and what we want are VN classification observations that we can actually work with. So I take every element from my my observations array using $0 to get each element, and convert that to a VN classification observation. This is the first step. And FlatMap converts now all of these objects and converts it into an array of objects and puts it into this classifications object. And now the cool thing is that we can continue working with that and not only flat map this, but we can also filter something right here. And also using these curly braces for our transformation, we can again take each object and access its confidence property from the vision framework. And the confidence property lets us choose objects. Let's say we only want to get results, or we only want to have classifications that have a confidence of 80%. So everything that is below 80% is nothing that we are interested in, because then it's the wrong digit that was recognized. And you can actually play along or play around with these values depending on the machine learning model that you're using. There is no golden rule for the confidence that you have to enter here. And the last thing that I'd like to do is actually map all my results now. And what I would like to transform here, or the transformation that I'd like to do here, is taking again each element and just using the identifier, because this is a string that we can work with now. And at the end, after all these three operations, this classifications array only holds the strings with the identifiers, or actually the digits that we want to display on our user interface, or the digits that were recognized from our handwriting. And all I need to do now, actually, since this happens asynchronously to the main thread, is using the dispatch queue, now using the main queue, and perform some code. And I want to update my user interface here using my digit label, access its text property, and using my classifications array, and actually its first object, because there only should be one object with the confidence of 80%. And this should be the digit that we plan to recognize using our handwriting. And now this is actually all there is to the recognition that we have to do when it comes to the vision framework, but we still have to start the recognition process when we hit the recognize digit button. And I have experimented a little bit with that, and what I have found is that the vision framework actually does everything for you in processing the image and putting it into the MNIST model. But the results are a little bit better if we actually scale the image down a little bit first, because as you remember, if we have a look at the MNIST model, it is required to have a 28 by 28 pixel image, and the vision framework does that for us. But if we input the image in a 28 by 28 pixels ratio from the start, then the results are a lot better. At least that is what I have figured out. So first of all, let's get our image. And we have already created a nice little function to get a UI image from our view, because now we can simply initialize a UI view, UI image with a view, and therefore we're using our canvas view. And that's all there is to getting an image. And now that we have this image, we actually have to scale that down a little. And therefore, I'm just adding another function here. Let's say scale image with an image, which is a UI image, to a specific size of a size, which is a CG size. And we want to return a UI image. And this is really simple. Again, using UI graphics, begin image context with options. We're using the size that we want to have. So the size would be 28 by 28 pixels. In our case, we don't want this to be opaque. The scale is 1. And then we use the image, draw this in a rect, defining CG rect with 0, 0 for the starting points, and the size and its width, and the size or the target size and its height that we have as a parameter. And then we create a new image using UI graphics get image from current image context. We're ending the operation using UI graphics end image context, and then we return our new image and unwrap this. This should definitely work. And now with that done, we can use our image now to create a scaled image, and simply call now assign and call the scale image function, scale image, and we're passing along the image that we've created, and the size that we want is a CG size with a width of 28 and a height of 28. And that's it. And now we can use an image request handler from the Vision framework using VN image request handler. We're initializing it with an image, a CG image, and options. Just made a little mistake here. Let me just quickly add this again. So we're adding a CG image. So I have to use my scaled image here and using the CG image, and then I unwrap this. And for the options, I simply pass along an empty dictionary because we do not need any options right here. And again, here, this is something that could cause an error. So I'm using a do try catch statement here, using try, using my image request handler, performing a request. And now I'm using my requests array that I've defined earlier and simply perform this array of requests. And if this goes wrong, then I want to catch my error using print statement here and printing my error. And that is all there is to it. And now we can run this in the simulator and see if we can actually recognize our handwriting. So here's our simulator. I'm now writing an 8. I recognize, and we have an 8. Writing a 4. This is not so beautiful, but it is still working, giving me a 4. Let's say a 3 here, and this also works. So this is really cool, and you've seen how simple it really is to work with this machine learning model together with the Vision framework. So this is something that I highly encourage you to do if you're working with image processing or a model that works with images or video. Then check out if you can use the Vision framework first with the Vision CoreML request, because this is sometimes very, very simple, or even simpler than just using the pure CoreML framework. And with that being said, I thank you so much for watching. If you liked the video, give it a thumbs up and make sure to subscribe to this channel if you do not want to miss any of these Christmas videos. We have still 22 videos to look forward to. So thank you again for watching, and I'll see you in the next one. Bye.